plus a constant. I don't need the constant because it's part of this thing. Okay, and this is integration by parts. This is the method of integration by parts. Okay, so this is integration by parts. Integration by parts for the indefinite integral. Okay. Now for the definite integral, for definite integrals, you get the same sort of thing. You say it's just the same, basically the same thing, but just definite integral u v prime equals negative the indefinite integral u prime v plus u v evaluated between a and b. So you just evaluate between A and B. You take this thing and then evaluate between A and B. Okay. So this is the trick of integration by parts. What does it say? I think people are still copying. Let me hold it. So this is the trick of integration by parts. You're still waiting. Okay, so this is the trick of integration by parts. What it says is that if you have the integral of u against v prime, then it's okay to take the derivative and pass it on to the other guy, right? If you have one function against the derivative of the other function, it's okay to take that derivative and move it over to the other guy. Okay? As long as you make some adjustment. You have to have a minus sign, and then you have to also throw in this other stuff. Okay? But that's sort of the idea, that it's okay to pass the derivative over to somebody else. Okay? Okay, so for yeah, let's do this one. So for example, the integral of x, natural log of x dx. Okay, so so you can think of it like this. So who are you going to choose as your who would you like to choose as your u, and who would you like to choose as your v prime? Let's choose this guy as the v prime, I'd say, because it's easier to do it that way. Okay, we'll choose this guy as the u, and this guy will be the v prime. Okay, so we're going to let u of x be natural log x. We're going to let v prime x be x. Okay, and what this says is that this is going to be equal to negative the integral of v. Right? Well, what's v? V is going to be x squared over 2. Right? V is going to be x squared over 2, and u prime what's the derivative of the natural log? That's just 1 over x, of course. 1 over x. Okay, so you get negative v u prime, so u prime times v, right, plus u times v. Right, so you end up with negative a half integral of x dx plus x squared over 2 natural log x. Right, in other words, you get negative a half x squared over 2 plus x squared over 2 natural log x plus a constant. Okay, that's good, because I think it's not so easy to figure out just by looking at it. If somebody said, what's the antiderivative of x natural log x? I can't figure that out so just by looking at it, right? But you can do it using integration by parts. Okay. There's sort of a notation that people use, sort of like an abbreviated notation. They write it like this: the integral of u dv equals the integral negative the integral equals negative the integral of v du plus u v. Okay, so in this one that we just did, you know, people would say, okay, I'm going to let the u be natural log x. I'm going to let dv be x dx. I'm going to let the dv be x dx. Then du is 1 over x dx. V is x squared over 2. Okay, and so this thing is going to equal negative, right? If this is u dv, so we're going to get negative v du plus u times v. Oops, negative the integral of u. In other words, negative 1/2 the integral of x dx plus x squared over 2 natural log x. Right? In other words, negative x squared over 4 plus x squared over 2 natural log x. Okay, so that's you know, we're doing the same thing. It's just a notation. Okay, so this is kind of cool, right? Because you know you can take the derivatives and pass them over to the other side. Okay. So let's see. Okay. Here's a funny one. Here's a funny one. Oops. Let me stick here's here's one for practice. Natural log of x, the antiderivative of natural log of x dx. Okay, so you're gonna need to choose your u, and you're gonna need to choose your dv. So what are we going to choose as our u? Natural log. And what's going to be our dv? 1 dx. Okay. So then our du is going to be 1 over x dx, and our v is going to be x. And then, so what does it say, right? So remember, the integral of u dv is minus the integral of v du plus u times v. Right? So this is the integral of u dv. We're going to say this is, we switch the derivative over to the other guy. And we say, okay, this is going to be v du plus u times v, right? Plus u times v. Right? So we get the integral of negative the integral of dx plus x ln x. In other words, we get negative x plus x ln x plus c. Any questions? Any questions on the method? Right. You have some integral, and you try to break it up into something that you can differentiate and something that you can integrate. Right? That's the thing, right? You want to choose your pieces carefully, right? So here I look at this thing and I think, well, I know how to differentiate this guy, so I'm going to use that as my u. I know how to integrate this guy, so I'm going to use that as my v prime. Okay. Similarly here, right, I don't know how to integrate natural log of x yet, so I'm going to choose that as my u because I want to differentiate it. Right? I'm looking for something I can differentiate. I know how to differentiate this. I'm looking for something I can integrate. Well, I can integrate the number 1. Okay. So you have to be sort of smart about how you break up your integral. Okay. Let me show you another example. Integral of x to the 5th e to the x cubed dx. So let me ask you to think for a minute to break it up, into something that you can integrate and something that you can differentiate. Right? What are you going to choose as your u? What are you going to choose as your dv? Right? As your v prime? Okay. Turn to somebody nearby and talk with them, please. Okay. Who would like to say what you're going to choose? What are you going to choose as your u? Say. E to the x cubed. Okay. And maybe dv is x to the fifth dx. Okay. Does anyone have other ideas of what they would choose? I'm actually not sure if this will go. Let's try it. Okay. Yeah, there's no guarantee that this will help out, but let's try it and see what happens. Okay. Okay. So then du is going to be what? 3x squared e to the x cubed, right? Dx, right? And b is going to be x to the 6 over 6. Right? So this will turn into negative v du, right, which is going to be 1/2 x to the 8th e to the x cubed dx, right, and then plus v du, which is x to the 6 over 6 e to the x cubed. Okay. Okay. So what do you think? Should we keep on going? It looks like, so this is true, right? There's nothing wrong with this. This statement is true, but it sort of makes you worry that we're heading in the wrong direction. Okay. Okay. Did anyone think of some other way to split this integrand into something you can integrate and something you cannot, and something you can differentiate? Something you can differentiate is easy, right? We can differentiate a lot of things, right? The hard part is something finding the thing that you can integrate. Okay, so so here's one thing that you could try. You could say, well, look, I'm going to take as my dv, I'm going to take x squared e to the x cubed dx. Right? Because you actually can integrate that, right? I'm going to take my u as x cubed. Okay. Right. Du then is 3x squared dx. V is going to be it's going to be 1/3 e to the x cubed. Right. So we end up with negative v du, right? So we get x cubed e to the x squared e to the x cubed dx plus x 1/3 x cubed e to the x cubed. Right. But that's good, and we're lucky. We actually can integrate that, and so we get negative 1/3 e to the x cubed plus 1/3 x cubed e to the x cubed plus c. Right. Okay. Any questions about that one? Wang Bo, do you have a question? This part? This part? I'm not sure. I'm not sure. This part. Yeah. So right here we have our u dv. Right. That's getting minus v du plus uv. Right. So we get v is this thing. Du is this thing. Right. When we multiply them, the 3 and the 1/3 are going to cancel out. We get x cubed e to the x squared e to the x cubed dx. Right. Okay, so we get negative that plus uv, that's this times this, so that's 1/3 x cubed e to the x cubed. Okay, that's right. Okay. And then you just evaluate that and you get this. That's the end. Is it okay? Yeah. Okay, good. Yes?
I don't understand how you got the equation on the top.
This one?
No.
This one? Okay, yeah, you missed it. It's actually just the product rule. Yeah, it's just a product rule. So remember, like, if I have u times v and I differentiate it, right? What do you get? Well, you get u prime times v plus u times v prime, right? Right. Okay. So then, what does this say? It says that u dot v is the antiderivative of this right-hand side. Right? If u dot v, if the derivative of this is that's the same thing as saying that this guy is the antiderivative of this. Right? Okay? Okay, so then I rearrange this. I'm going to say this is u prime dot v dx plus u dot v prime dx. Okay. And then I'm going to pull one thing to the other side. So I get u is equal to negative u prime dot v dx plus u times v. Okay, which is abbreviated. We sort of abbreviated as this. Okay, so this is the product rule. This is what we call. I'm sorry, not the product. This is what we call the integration by parts. So product rule gives integration by parts. Does it make sense? Okay. Yeah. So yeah, if you ever forget integration by parts, just think about the product rule. Right? You know the product rule. You all know the product rule. Just the derivative of a product is the first guy times the derivative of the second plus the second guy times the derivative of the first. Right? And then you think what that says in terms of antiderivatives, and then you do some rearranging, and out pops the technique of integration by parts. Okay. Okay. A couple more. How much time do we have? Okay, we're good. Okay, a couple more. Here's a funny one. The antiderivative of the arc sine. The antiderivative of the arc sine. So what are we going to choose as our u? Definitely, we're going to choose this thing because we don't know how to we don't know how to integrate it. Right. What are we going to choose as our dv? Again, we're going to choose just the function 1. The function 1. Does anyone remember the derivative of the arc sine? If you don't, that's okay. It's I don't remember either. It's 1 over the square root of 1 minus x squared. And then v is going to be x. Okay. So again, writing this out, we're going to get v du, right, minus the integral of v du plus uv. Right? And you see what happens, right? You're going to get 1/2 x divided by 1/2, so you get this, right? Plus x sine inverse x plus some constant, plus constant. Is that clear? So maybe there's one part that's not completely clear. Let's look at the integral of x 1 minus x squared to the negative 1/2. Right. How do you integrate this? What will you use to integrate this? Maybe u substitution, right? You use your u substitution. You'll take your u as 1 minus x squared, right? Then du is going to be negative 2x dx. So you end up with negative 1/2 the integral of u to the minus 1/2 du. But that's negative 1/2 u to the 1/2 divided by 1/2 plus c. Right, and so we end up with negative 1 minus x squared to the 1/2 plus c. Okay. That's all right. At the University of Chicago, there was one professor who, I never saw this happen, but apparently if somebody's phone went off in class, he would take it and then he would destroy it. Yeah, I never saw this happen. I think I took one class with this professor, but I never saw it happen. Okay, so let me just show one last funny thing. Okay, e to the x cosine x dx here. Okay, so here's one sort of funny thing that can happen when you're doing integration by parts. So let's say that we're going to take u to be cosine x, and we're going to take our dv to be e to the x dx. Okay, so let's do it. Right, du is negative sine x dx. V is e to the x. So we get negative v du, right, so e to the x negative sine x dx plus e to the x cosine x. Right? Okay. So now let's keep on going. We have this integral, right? So maybe we're going to do the same thing. We'll say let u be sine x, and dv be e to the x. Okay. du then is cosine x dx, and v is e to the x again. Okay. So we keep on going, and we say, okay, this is going to be negative. This integral here is negative e to the x cosine x dx plus e to the x sine x, right? U times v. And we also have the e to the x cosine x left over from here. Right? Okay. So then we have this integral, e to the x cosine x, right? So maybe we're going to keep on going and let u be, should we keep on going like that? No, because then we'll just die. Eventually we'll die. Okay. Right? So you could keep on going back and forth. That's the trouble. Right? You could keep on going back and forth, but you're too clever to do that. And instead you notice that what we have is that the integral of e to the x cosine x, e to the x cosine x equals negative the integral e to the x cosine x plus these other things, e to the x sine x plus e to the x cosine x. Okay. So that actually gives us information about our integral, right? Let's move this thing to the other side and then divide by 2. Right? Divide by 2, and that tells us that our original integral equals 1/2 of e to the x sine x plus e to the x cosine x. So this sort of thing sometimes happens when you're doing integration by parts. Well, there's actually 8 minutes left in class. I'm not sure if I should start the next subject or if I should just let you go at this point. If I start the next subject, there's not really enough time. There's not really enough time to do it. I guess I'll just let you go.